Hey everybody, I'm just going to give a quick summary of the stuff that we did in geometry class on January 3rd through the 7th. So this is basically what happened over the course of the week. I know a bunch of you were gone, so I think that this might be helpful for some of you. On Monday, we went over some missing angles. I'll explain what that meant. Also just like some regular like back to school stuff. Tuesday, we did this again, but it was kind of tiered, meaning that there were like some really simple problems and some really, really challenging problems, and people kind of picked their own adventure. Wednesday, we did something called the triangle inequality theorem. Thursday, we worked on side angle relationships. And on Friday, if you remember, it was super, super cold, and not that many kids came to school. I think I was at about 40% attendance for all of my classes. So we did some review and some extensions. So let's dive into each of these. You can, of course, fast forward through the video. I will title each page of like Monday, Tuesday, Wednesday, Thursday, Friday. So if you missed Wednesday, you could just fast forward to where it says Wednesday at the top. So on Monday, this was our first day back from winter break. The goal was really just kind of remind everybody all of the things that we had worked on. And so I gave students these 6 problems, which review kind of big ideas. I'm just going to do a couple examples. The answer key is definitely up on the Google Classroom. If you look at under like week 7, January 3rd through 7th, Monday 1-3 summary, there's a PDF in there and that's got answers, but we'll go through just a couple of them real quick. So like here, basically I'm just trying to remind you of a couple different things. So if this angle right here is 57, then the angle straight across from it is also 57 degrees because they are vertical angles, if you recall that from way back when. And then to find this missing angle, you got to notice this is a triangle, and since it is a triangle, this angle, and this angle will sum to 180 degrees. So you can add 81 and 57. Well, 80 and 50 would get me 130. And 1 and 7 would get me 8, so that added up to 138. And then what do I need to add to that to get to 180? That's going to be my missing angle, and so if I added 2, that would get me up to 140, and another 40, so this would be a 42 degree angle. So, geez, that's not how you write 42. So that would be my missing angle there. So again, just vertical angles, that's what we're trying to review, and then the sum should be 180. Other stuff, so a problem like this, where you're given here, you've got 148. This angle right here must combine with the 148 to get to 180. So think about, what do I need to add to 148? You need 2 to get up to 150, and then another 30. So this would be a 32 degree angle. Then you're at a triangle, so 132, that means this one would actually have to be 48, so that you get 180 degrees total. And then the question is, what's this going to be, so that the 48 degree angle and the missing angle adds up to 180, and that would be 132 degrees. So it was just kind of like shake off the cobwebs, make sure everybody remembers stuff from before break. So that was Monday. On Tuesday, as I said, it was kind of tiered, and you'll notice that this is a packet of questions that everybody got. There were 8 questions, and those kind of corresponded to about what you could expect to get on a test. So if you were only able to solve problems 1 and 2, you could probably expect to get about a 2 on a test, and that's just passing. A 3 would get you up to a D, maybe a C minus. If you wanted to get a higher C or a B, you want to be able to solve 4 and 5. If you want to get up to B or A range, you'd want to be able to solve 5 and 6. And then obviously you want to get an 8, which is like your super A, and you'd want to be able to solve this one. So just real quick, let's look at kind of what's going on in these problems. This is my answer key. Here, these are just triangles, and you're looking for the missing angle. So add up 2 angles, figure out what you need to add to get to 180, and that is your missing angle. So for example, here I added 86 and 47, I got 133, subtracted from 180, found that it was going to be 47. Same thing down here. So if you can just find the third angle in a missing angle, you're probably going to get about a 2. Okay. If you are wanting to do a little bit better than that, then maybe you're going to throw in something like using vertical angles. So over here, this was empty, and this is, of course, empty as well. So use these three, again, add these two together, subtract from 180 to figure out the 67. If this one's 67, that's definitely going to be 67. And then same, add up to 180 to figure out what Q is. Let's skip over 4 and look at 5. Here we started using stuff like the fact that we have two angles that are identified as being equal to each other. So in this case, you would know that this 48-degree angle plus this giant big red angle would add up to 180. And so in that case, you could figure out that that giant red angle is 132, which means divide it by 2, and you'd get that each of these angles, so here is 66, here is 66, and that would help you get this angle because here you've got 90, 66, and a missing angle. So that's like getting up into like a low B range if you're able to solve problems like that. Here is problem 6. This required that you were doing a lot of kind of like, okay, if this is 133, that's going to be 47 because these add up to 180. These two would be 47 then. You might have used the fact that A, 40, and 71 add up to 180, and actually I think I've got a mistake on here, so let me get rid of that. I'll fix the, if you check online, I've got the correct answers up. Here, again, similar ideas. You probably may have even needed to use the fact that this has a 5-sided shape, and anytime you've got a 5-sided shape like this, that's the same as this would be 180 degrees total, this would be 180 degrees total, this would be 180 degrees total. So the 5 angles, like that red, that red, that red, that red, and that red, add up to 3 times 180, which is 540 degrees. So you probably had to use that at some point to solve this problem. For 8, to get all the way up to an 8, if you are able to use the fact that you've got some equal angles here, so I think you had to use 66, that these two are equal, and this one in this giant triangle to solve, that's helpful. Here you got some parallel lines, which means that we have some like alternate interior, or sorry, same side interior angles. So these two add up to 180. These are going to also add up to 180, things like that. So that was Tuesday. So just kind of like reminding ourselves kind of where we are. New content, again, started on Wednesday. On Wednesday, we worked with something called the triangle inequality theorem. And the triangle inequality theorem is kind of a funky little thing. And basically what it says is it is saying if you have 3 side lengths of a triangle, is it possible for you to actually make a triangle out of them? So I've got 3 side lengths here, and I'm kind of messing these around. Let's see if I can actually turn this so that it works. Boom. Okay, great. I made a triangle out of these 3 side lengths. Let's see if we can do the same thing over here. I'm going to move this here and here and start turning this guy around. Okay, so it's connected there. Hopefully you're seeing that it doesn't really matter what I do with either of the red or the blue ones. If I can turn the red, and I don't know if it might even be too small for me to turn. There we got turning the blue at least. There's no way that I'm going to be able to make a triangle here. And so what we did on Wednesday was kind of play around with this, and what we found was this rule. Any 2 sides of a triangle must sum to be larger than the third side. So like if you took this red and this blue and you added them together, let's say that the red is 3 centimeters and the blue is 5 centimeters. Then if you added these together, that would have to be longer than the green one. So the green one reasonably might be something like 7 centimeters here. Whereas over here, I've got this big long green one. Let's say this is 11 centimeters. The red one is 1 centimeter. The blue one is 2 centimeters. And so what we have in order for you to get a triangle is that in this case, 3 plus 5 has got to be larger than 7. Whereas over here, if you have 1 plus 2, that is not larger, so than 11. Like this right here is super not true. And so like sad face, fail, doesn't actually work. This means that you cannot actually get a triangle. Now, the same thing must be true for all of the other ones. If you add 7 and 5, that's bigger than 3. If you add 3 and 7, that's bigger than 5. So it must work for all of them, right? If you did 2 and 11, that's definitely bigger than 1, but that's not enough. All of the pairings have to actually work, where the two sides must be larger than the third one. So this is useful just to know, like, is it possible to even make a triangle from these three sides? And as we get into the Pythagorean theorem, which is going to happen here pretty quick, people can make some pretty silly mistakes. Like if they thought this was 5 and 8, and then they did all of this work to figure out what this missing side is, and if they happen to tell me that this missing side is 15, then we know that we've run into a problem, because 5 plus 8 is not bigger than 15. Like, uh-oh, something's wrong. Like, there's a problem. I must have done something wrong, so I'd go back and check my work. So this was Wednesday. On Thursday, we covered something called side-angle relationships. And basically what we ended up doing was everybody got some triangles. We had them measured with side lengths, so that's like this 569 here, and angles, so 34 degrees here. And then what I asked everybody to do was to highlight. So what they did was, in yellow, they highlighted both the smallest sides and the smallest angles. Then in green, and these colors might not match what we did, but for our purposes, they'll be fine. So let's go through and do that. So the smallest side, if we are looking at this triangle, is definitely this 3 2/10 unit. So I'm going to highlight that in yellow. Here's my smallest side over here, 3 200ths, and then that's 264. And then the smallest angle, in this case, we got 34 over here, we got 18 over here, we got 53 over here. Middle length, 4 and 2, 455, 283, and then my middle is going to be that one, and that one, and that one, and then my largest here, and that's the largest angle, here, and that's the largest angle, here, and that's the largest angle. And then we just ask students to kind of notice what you see and what most people came to do. And obviously, if you'd like to take some time, pause and notice yourself before you keep going, is that the colors are opposite each other, right? So the smallest side is always opposite the smallest angle. One of my students put it a really nice way. They said that, like, the angle arc, like if you looked at this yellow angle arc, doesn't touch the yellow side. The green arc doesn't touch the green side. The orange arc doesn't touch the orange side. And that is true for all of these triangles. We had a whole bunch of different triangles, and it is always going to be the case. So the side angle relationships that we noticed, and again, this is going to be really useful when we start solving for stuff, is that if you are looking at solving something and you happen to find out that this is your biggest angle, but this is your smallest side, like something has gone wrong when you've done it. So it will always be true that the smallest side length will be opposite the smallest angle, the largest side length will be opposite the largest angle, and the medium side length will be opposite the medium angle. So that was Thursday. Like I said at the beginning, Friday was a bit strange just because there were so few students in attendance because it was super cold. It was like -20 before the wind chill. And I know that there were a lot of people out because of quarantining and or COVID, so each teacher kind of did what they wanted. In my class, Miss Perkins' class, we looked at triangles on spheres. So I want you to imagine a dude like standing at the top, like the North Pole, and then walking in a straight line all the way down to the equator, and then turning and walking along here. So then clearly like 90-degree angle right there, right? Walks all the way over, maybe over here, and then turns and goes back up to the equator. Well, here you'd also have a 90-degree angle, and here you'd actually also have a 90-degree angle if you went a quarter of the way around the Earth, which means now all of a sudden you did 3 straight lines on a sphere, and you ended up with a triangle that adds up to 90, 180, 270 degrees. That's way more than 180 degrees, which let us figure out something which is kind of cool, which is triangles have 3 angles that should say some, goodness gracious, sorry, some to 180 degrees only if they are on a flat surface. This is not a flat surface. This is a spherical surface, and so triangles do weird stuff when you're on a sphere, which I thought was kind of fun. But this is not a thing you're going to get tested on. I'm just letting y'all know in case you were not in class. So hopefully this gives you a good idea of kind of what we did over the course of the week. Please let us know what questions you might have, and I hope you're taking care of yourselves. Bye, everybody.